All right, we're back with 11.2, page 2. We've got this activity. Unfortunately, I do not have a protractor at my house. There's one at school, there's plenty at school, but not here. And you may not have a centimeter ruler at home. Might have an inch ruler. You can use whatever you want to measure the sides. I am going to use the handy dandy stick of justice. All right, got his mask on, he's ready to go. Oops, there we go. So, we're gonna classify this triangle. So we're gonna measure the sides. So I'm gonna measure the sides to start us off. AB is about 13 centimeters. I'm gonna write 13 centimeters, 13 cm. BC is about, looks like 9 centimeters. All right, and then A to C is, looks like 19 centimeters. All right, so what type of triangle has 3 sides of different lengths? We've got 19, 13, and 9. Remember, scalene is kind of like the weird looking one. It's scaly and strange. So this is gonna be scalene. All right, and to measure the angles, if you don't have a protractor, like I don't have a protractor, you're gonna use a sheet of paper. So cool thing about these papers are, these are 90 degrees. If an angle is bigger than this, it's obtuse. If it's smaller than that, it's gonna be acute. And all I've gotta do, if I wanna measure angle ABC right here, this angle, I'm just gonna put my paper right there. And if you'll notice that the line comes out this way, that means it's obtuse. If it was going straight down, this would be a 90-degree angle. All right? So if it was straight down, it'd be 90. It's bigger than that, so this is an obtuse angle. If it was underneath it, it would be acute. All right? So this is an obtuse angle. I know this already. That is bigger than 90 degrees. I don't know why I did that. Okay, I can do the same thing here. So AB, if I put my paper on the line and on the vertice, if you look that the line goes underneath the paper, that means it's acute. And you can pretty much tell that's acute just by looking at it. Okay, so I've got this obtuse angle. This is obviously also acute. If I put my paper right there, ACB, it goes underneath the paper, not outside of the paper. This is acute. And that makes sense if this is obtuse, right? That the other two are gonna be acute. So we've got an obtuse. All right, so this gives me ABC is a scalene obtuse. All right, down here we're gonna do our own drawings, which you know, not my forte, so I'll do my best to give you some pointers. But triangle by length of sides, triangle by the angle measure. We've got scalene, which means that I have how many different sides? 3 different sides. And it's acute, which means all my angles are less than 90 degrees. In order to do this, okay, I'm gonna go here, make sure that I'm less than 90 and just slightly longer. Okay, and then I'm gonna go like this. So I'm gonna say that these are all different lengths. So I'm gonna label them to make sure people know. 3, 4, 5. All right, and I'm gonna do isosceles. I want acute, so I'm gonna start up here, come down, and then come down the same distance, boom, and then I'm gonna mark these as being the same length. That's how I'm gonna make sure people know. All right, same here, obtuse. I wanna start with an obtuse angle, so I'm gonna make something really, I'm gonna go like this, and then something like that, so that it's really long. See how my angle is obtuse? If I take my piece of paper and I put it here, the line sticks outside of it, then I'm just gonna connect it. Right, and I'm gonna call this 3, 4, 5 again, just so people know that the lengths are different. And then for isosceles, I wanna do the same thing. I want a really wide angle at the top, so I'm gonna come out almost flat. All right, put my paper there. See how that's obtuse? And then I'm gonna connect them. And then I'm gonna draw my little lines. So something along those lines. You could use a ruler to make sure that it was perfect, and a protractor, and make a perfect scalene acute, or isosceles acute, or obtuse. So, all right, that's page 2, easy peasy. Next page.